Silurian ecosystems depended heavily on algae, which contributed to reef growth, primary productivity, and even the earliest steps toward land plants. Algae were not background organisms but key players in shaping marine and freshwater ecosystems, providing the foundation for food webs and stabilizing environments. Red algae, or Rhodophyta, had already established themselves as silent reef builders. Their calcium-rich skeletons provided structure in shallow waters, helping stabilize early coral reefs and creating habitats for countless marine organisms. Though their fossils are rare, their impact was profound, adding strength and complexity to Silurian reef systems. Alongside them thrived the green algae, or Chlorophyta. These were the true engines of primary productivity in coastal waters. Through photosynthesis, they formed the base of food chains, converting sunlight into energy that supported trilobites, mollusks, and other marine invertebrates. Their mats covered tidal flats and shallow bays, binding sediments and keeping the coastal environment stable. For countless organisms, they were both food and shelter, ensuring the Silurian seas remained vibrant with life. But perhaps most significant were the early charophytes, freshwater algae that had already begun to push into new environments. Unlike their marine relatives, they lived in ponds, streams, and estuaries, and their cellular structures made them strikingly similar to the first land plants. Modern studies confirm that charophytes are the closest living relatives of true plants, and in the Silurian they represented the experimental stage where the boundary between water and land began to blur. Together, these three groups, red algae, green algae, and charophytes, formed a living continuum. They linked ancient marine photosynthesizers to the first vascular plants, and in doing so, they held the key to one of evolution's greatest transitions, the greening of the continents.